Here we'll be learning about the Kirchoff's law. We have two main laws. The first one is called the junction law, which is related to current, and the second law is called the loop law, which is related to voltage. Now let's talk about the first law, which is the junction law. Here, the definition of the junction law is that the sum of current entering a junction is equal to the sum of current leaving the junction. For an example, let's say we have a junction, and here the currents I1, I2 and I3 are entering the junction, while I5 and I4 are leaving the junction. Therefore, according to the junction law, we can say that I1 plus I2 plus I3 is equal to I4 plus I5. Now let's move on to an example. Here we have to find I1 and I2 using the junction law. Let's consider this as junction 1 and this as junction 2. So if we consider the first junction, we can say that I1 is equal to 6 ampere plus 3 ampere, which will be 9 amperes. And if we consider the second junction, we can say that I1 is equal to I2 plus 2 ampere. Therefore, I2 is equal to I1 minus 2 ampere. Since I1 is 9 ampere, we will get the answer I2 is equal to 7 amperes. Now let's move on to the second law, which is the loop law. The definition of the loop law is that along a closed loop through which current flows, the sum of potential drops across each component is equal to the sum of potential increments. There are steps to be followed when applying the loop law. The first step is to mark current on each branch of the circuit. The second step is to mark the direction of increment of potential. For cells, the potential will increase from the negative terminal to the positive terminal, and for resistors, the potential will increase in the direction opposite to the current flow. When moving in either anticlockwise or clockwise sense in a loop, the increase in potential should be added and the decrease in potential should be subtracted. And when we get the algebraic sum, it should be equal to 0. Now let's apply those steps to this circuit. First, we have to mark the current. Let's say this is I. And now we have to mark the increment in potential. So if we consider this cell, the potential will increase from the negative terminal to the positive terminal. This is the negative terminal and this is the positive terminal. So the potential will increase from negative to positive. And similarly for the cell E2, the potential increment is from negative terminal to positive terminal. And if we consider the resistors, the potential will increase in the direction opposite to the current flow. So the current will be flowing in this direction. Therefore, the potential will increase in this direction. And it is the same for resistor R2. Now let's apply the loop law. I'm applying it in the clockwise sense. Here, if we consider the E1 potential, it will increase in the same direction as the sense I have considered. So E1 is positive and R1 is in the opposite direction. So that will be IR1, and E2 is in the opposite direction. So it is minus E2, and R2 is in the opposite direction. So it is IR2, which is minus, and the algebraic sum is equal to 0. Therefore, E1 minus E2 is equal to I R1 plus R2. So we can say that sigma E is equal to sigma IR. Now let's move on to the second example. First of all, let's mark the current. This is I1, and if this is I2, this will be I1 minus I2 according to the junction law. And next, let's mark the direction of increment of potential. It is from negative to positive for cells, and for resistors it is in the direction opposite to the current flow. So it will be like this. And now we have two loops, this one and this one. Let's call this P and this as Q. And if we consider loop P in the anticlockwise sense, this will give us 14 plus 10 and minus I times 4, this is I1, and minus I2 times 6 is equal to 0. Then we get 24 is equal to I1 times 4 plus I2 times 6. And if you simplify this by dividing by 2, we get 12 is equal to 2I1 plus 3I2. That is our first equation. Now let's consider the loop Q in the clockwise sense. Then we will get 10 minus I2 times 6 plus I1 minus I2 times 2 is equal to 0. Then we get 8I2 plus 2I1 is equal to 0. That is 10 is equal to 8I2 minus 2I1. If we now let's name this as the second equation. So if we add the first equation with the second equation, minus 2I1 and plus 2I1 will get cancelled off. Therefore, we will get 12 plus 10 is equal to 8I2 plus 3I2. Therefore, 22 is equal to 11I2 and I2 will be 2 amperes. And using the second equation, 10 is equal to 8 times 2 minus 2I1. Then we get 2I1 is equal to 16 minus 10. Therefore, I1 is equal to 6 divided by 2, that is 3 amperes. Therefore, using the loop law, we can find unknown currents in a circuit. Now, let's move on to the next example. Here, we have to find the values of EMF, E1 and E2, and also VAB, that is the voltage at A with respect to B. Here, B is grounded, therefore the voltage is 0 watts. Now, the currents are already marked, therefore we can mark the increment in potential. For the battery, it is from negative to positive. And now let's mark the loop. Let's call this as the P loop. and I'll take an anti-clockwise sense, and this as the Q loop, I'll take the clockwise sense. Okay, now let's apply loop law to the P loop. Here we have to mark the increment in potential for the resistors as well. So the current flows from here, therefore the increment is from left to right. Here the current flow is from right to left, so the increment is from left to right. Here the current flow is from left to right, so the increment will be from right to left. Okay, now let's mark the, now let's take the, now let's apply the loop law to loop P. Here 20 is positive and E1 is negative. Next we have the resistor. It is opposite to the sense we have considered, so that will be -7, and E1 is in the same sense, so sorry, the 5 ohm one is in the same sense, so that will be 5 times 1, and the total will be equal to 0. Therefore 20 minus E1 minus 2 is equal to 0. E1 will be 18 watts. Now let's apply the loop law to loop Q. Here E2 is positive and E1 is negative, and 3 times 2 plus 5 times 1 is equal to 0. Then E2 minus E1 is 18, and we have 11 here, so E2 will be 7 watts. Now we have to find VAB. VAB can be written as VA minus VB. Since the circuit is grounded at B, VA VB will be 0 watts. Therefore VAB is equal to VA. Now let's redraw to the diagram. This is point A, this is point B, which is grounded, and here it is 5 ohms and E1 is 18 watts. Here current flows from B to A. Let's mark this point as C. The current is 1 ampere. So VB minus VC is equal to IR, that is 1 times 5. VC is equal to minus 5 watts. And also VA minus VC is equal to 18 watts. So VC is minus 5 watts. Therefore VA is equal to 18 minus 5 watts, that is 13 watts. Therefore VAB is equal to 13 watts.